Hello students. So today we will be covering HCF and LCM, and this is a very crucial topic in numerical ability. You're likely to get few questions on this topic in your exams, and especially in NATA and NIFT. And it's also important to learn this HCF and LCM because of its application to other areas of mathematics. For example, when you are adding or subtracting fractions, you will require to find out the LCM of denominators. Again, when there are problems related to grouping, HCF might be required. That's why it's important to learn this topic. So we will do that now. So let us start. So this topic is divided into three parts. In the first part, we'll understand HCF and LCM and we'll explore the different methods to find them. In the second part, there are formulas and tricks which will help to solve the problems efficiently. And in the third part, there are questions, the different types of questions, and also previous years, previous year questions. So let's recap some terms before learning it. Like there is factors. Factor means a factor of a number is the number which completely divides that number without any remainder. Like for example, the factors of 8 are 1, 2, 4, 8. It means if you divide 8 by 2 or 4 or 8, any of these four numbers will not get any remainder. So these are the factors of it. Similarly, multiples. Multiples of a number is a number that is the product of the given number and some other number. Like for example, multiples of 8 will be 16, 32, 24. All these are multiples. Now another is a term we should remember because this will be used is prime factorization. It means it is expressing a number as a product of its prime factors. Like for 8 we can write as 4 into 2 also, but that will not be prime factorization. Prime factorization means divide this, expressing this number, that means 2 into 2 into 2, all these are prime numbers, breaking it out so that all the numbers are prime. So like 24, 2 into 2 into 2 into 3. So this is prime factorization. So now let's come to HCF and LCM. HCF is highest common factor. We just now learned factor. So this is the highest common factor, and another name for it, greatest common divisor, GCD. So highest common factor of two or more positive integer is the largest positive integer that divides the number without leaving a remainder. That means like if there are numbers are 8 and 12. So the largest number which can divide both the numbers, like 4 is the such number. So the factor of 8 is 2 also and 4 also. 2 can also divide both the numbers, but that is not the highest. So that's why 4 will be the HCF, not 2. Now again the second term is we have to learn is LCM. LCM means least common multiple of two or more number is the smallest or least positive integer that is divisible by each of these numbers. That means basically we are looking for multiples, but multiples of all the numbers, like for here 8 and 12. So we are looking for a number which is a multiple of 8 also and 12 also, and that should be least. Like 48 is also a multiple of 8 also and 12 also, but that is not the least. 24 is the lesser of them. So here the answer for this will be 24. There are two methods to find HCF and LCM. First one is factorization method and second one is division method. HCF by factorization method. So what we do here, first we prime factorize each number. Then we find common prime factors, and HCF is the product of all the common prime factors with the lowest exponential power. Let me give you an example, like for example 24 and 36. So the prime factors are 2 into 2 into 2 into 3, and prime factors of 36 is 2 into 3 into 3. So if you have to find out HCF, we will see the common factors. The common factors are 2 and 3. We will take the lowest exponential power. The lowest, the power for 2 is 2 and for 3 is 1. So that means the HCF will be 2 into 2 into 3. That means 12. So here the answer will be 12. Now again for this 75 or 180, again we'll find out the prime factors. So for 75 the prime factors are 3 into 5 into 5. And for 180 the prime factors are 2 into 2 into 3 into 3 into 5. Now common factors which are common to both are 3 and 5. So HCF will be 15. HCF by division method. So what we do here, We divide the larger number by the smaller number, and whatever is remainder is there, that becomes the divisor, and the divisor is divided by that. So divide the divisor by the remainder, and we repeat the process of dividing the preceding number by the remainder last obtained till 0 is obtained as the remainder. The last divisor is required HCF. And what if there are more than 2 numbers or 3 numbers? So then in that case we find the HCF of two numbers, any two number, and HCF of the above obtained number and the third number will give the HCF of 3 numbers. Similarly, the HCF of more than 3 numbers may be obtained. So to make it more clear, because it might have become confusing, so let's see, for example, these are the two numbers. So what we will do here, we will take the smaller number and we'll divide the bigger number with that. So 36 if you divide by 24, it will go by 1, here 1, and they will get, this is the remainder. Now this will become the divisor, and this one comes here. So here remainder came this 0, so this is the HCF. If in case there would have been remainder left, then again we would have repeated the process until we get the remainder 0, and the place where the remainder has become 0, that particular whatever the divisor is, that is the HCF. Let me show you one more example, like 75 180. We will divide 180 by 75, we'll get 30 as the remainder. So this will become divisor now, and this will come here. Again we get 15 as remainder. Again it will become divisor, and this divisor comes here. So now the remainder is 0. So here the HCF will be 15. LCM by factorization method, we prime factorize again each number. And LCM is the product of highest exponential power for all the factors. Here we are not taking common, but all the numbers whichever are there. Like for example 24 and 36. If we take out the prime factors, it's 2 into 2 into 2 into 3. And 36 is 2 into 2 into 3 into 3. So LCM will be, we'll take all the numbers, to their numbers are here 2 and 3, and we'll take the highest exponential power. So it will be 2 to power 3 into 3 to power 2, that will be 72. Similarly for LCM of 75 and 180, the prime factors are 3 into 5 into 5, and 180 is 2 into 2 into 3 into 3 into 5. So now for LCM, the factors are 2, 3 and 5, 2, 3 and 5. So we'll take the highest exponential for all the factors. For 2, the highest power is 2. For 3 again 2, and 5 also 2. So it will be 2 into 2 to the power 2 into 3 to the power 2 into 5 to the power 2. That is 900. The LCM by division method. So what we do here, we arrange the number in any order. That order is not important. Now we divide by any prime number which divide exactly at least 2 of the given numbers. And whichever number which is not divisible, we'll just carry forward them. Then we'll repeat our process till no 2 of the numbers are divisible by the same numbers except 1. So now the product of the divisors and the undivided number is the required LCM of the given number. For example 24 and 36, we will divide first by 2, we'll get 12 and 18. Again we will divide by 2, we'll get 6 and 9. Again we will divide by 3, we'll get 2 and 3. Now we are not able to divide by any number. So now the LCM will be product of all these numbers, all the numbers on this side and this undivided number. So LCM will be 2 into 2 into 3 into 2 into 3. So that will be 72. Similarly for 75 180, first if we divide by 5, then we get 15 and 36. This number we can see is divisible by 3. So it's 3, 5 and 12. Again no number can divide both. So we'll get the LCM by multiplying all these numbers. That is 5, 3 into 5 into 12. So it is 900.